Well, this is now your title animation template. So your title here and your subtitle here. There you go. So then you can sell this or have this as a download somewhere. And then all someone will have to do is download your template and plug in their own text here. And it will look exactly like this with their own text. All right, welcome back to Blender Frenzy. I am Justin, and if you've been following the past couple of tutorials, this is what we have made. So this is the result of our text fading out and fading in. You can see we have a couple keyframes. So if you're just jumping in here in the middle and you want to follow along, you have a couple of options. First, you can go back and watch the 2 previous videos that I made. The first one, I'll show you how to use regular text and a material, a gradient texture. And then we use an empty to control the motion of the gradient texture to fade in and out the text. In the video after that, we do the same exact thing, except we bring it into geometry nodes and try to create the same result. Now, because in Blender, the position of textures relies on the origin point, and in geometry nodes, the origin doesn't move with the instances, we had to create a couple of hacks to work around that. So we ended up using inputs and drivers on these sliders in order to control the motion of the gradient. So that's the first option, but if you don't want to watch those videos and create it yourself, you can always go to blenderfrenzy.com and you can sign up to the Frenzy freebies and get this download for free, or you can start right where I'm starting today. You can go and see what's all inside. There's a whole bunch of different downloads. I've got 3 tiers. We got the Frenzy freebies, where you can download free stuff to follow along with my YouTube tutorials. I've got a Plus and a Pro. The main difference between these is this is just extra videos, and then this is everything, extra videos and downloads. So if you're jumping in the middle, you don't want to do all the work, you can download this very blend file that I'm starting with, which is what we're going to do right now. So if we select our text and disable our overlays for just a minute, we can see our keyframes here that are driving the animation that we have. So if we press play, you can see we've set these keyframes manually, and this is fine, but there's not a lot of difference between using the geometry nodes versus using the regular text and the empty just in regular 3D space. And so this just means we're not leveraging the power of the procedural aspect of geometry nodes to its full potential. So I'm going to go ahead and get rid of the orange text here for now just to demonstrate this. So right now we've got this animation which works just fine, but let's say I want to change the text. So let's do geometry nodes is the bomb.com. Okay, so now we have a problem. If we play this, you can see that our animation only goes to about a little over half of our text. Now, of course, we could just replace this keyframe, drag this out, make another keyframe, and then you have it. But again, that's not using the power and the potential of the procedural aspect of geometry nodes. What I want to happen is to set 2 keyframes and never have to adjust them again and have the animation of the text revealing or being hidden. I want that to work on the entire string of text no matter how long or short this is. So basically if I change this to something like hi, it will work just the same way if I change it to I want to put a really long string of text here. So I want it to be full from start to finish here. And that is possible with geometry nodes, which is what we're going to get into now. So if you haven't been watching the first 2 videos that I made on this, over here is geometry nodes and over here is the shader editor with our transparency here. And this is just a little group that we made. If we tab into it, you can see all the stuff that's going on here. These purple sliders are the drivers for this slider here. So you can see the empty move is this with the 0.786. If I move this, it drives the position of this, which drives the position of the gradient texture. Gradient offset, same thing. That's this one here. You can see the numbers match. But I'm just going to pull this and minimize this here for now. We're going to work mainly with geometry nodes first, because the first thing we want to do is we want to make the empty itself start at the beginning of the string and then animate that to the end of the string no matter how long this is. So for starting purposes, I'm just going to type in geometry nodes here, and scroll in. And then I'm just going to right click and clear the keyframes here. Set this at 0. So now our empty is smack dab in the center of the world origin. And I should have renamed this text here. This top text here is, I'm going to press F2, blue text. And this would be the orange text. And I'm going to rename this here too to plain text. And the reason I have plain here is because if we disable our geometry nodes, it's on a plane that we put in our world. So that's what it's using, but we've replaced that plane with text. Okay, but I'm going to just disconnect the orange text for now because this is going to work on just a single text first, and we'll plug that in later, just so we can have a little bit more room to work with stuff here. So we need some way to calculate the length of any string that we put in here. And that's really easy. All we have to do is add in a bounding box and place that here. And now we have a bounding box that goes around every single letter, which is not what we want. So to change that, right before the bounding box, we add in a realize instances. Boom. Now we have a bounding box that goes around the whole string, no matter what we put in here. So if I just say geometry, it will fit whatever I have, because obviously it's the bounding box for the string of text we have here. And now with the bounding box, we have these two sockets that have a minimum and a maximum output, and that's what we're going to use to calculate the empty minimum and maximum. So let's bring this transform geometry over here, because this transform geometry, this is transforming our empty, which means it's just moving our empty. So if we disconnect this translation over here, this is the slider here that moves the empty. We'll just put 0 again there for now. And let's plug in the maximum and see what happens. Okay, so now the empty is in the top right corner over here, and that is because it's taking the maximum values of the x, y, and z, although there is no z because everything is completely flat, so it's completely 2D. So for our purposes, we only need the x and the y. So the maximum x is over here, and then the maximum y is up here, which makes this corner. And if we zoom in here and hover our mouse over the maximum, you can see that it's 7.1 on the x, 0.69 on the y, and 0, of course, on the z. And those are the numbers that are being fed into the translation here. So 7.1 and then 0.69 brings you here. So if that's the case, then which corner do you think is the minimum? So let's go ahead and see by plugging that in. Boom, now it's down over here. And that's because it's the minimum values of the x and the y. And if we hover our mouse over here, we can see minimum x is still positive, actually, because you can see it's to the right of the 0 world origin. So it's 0.5 or 0.05. And then it's negative 0.23 down on the y, bringing us down to here. Okay, so now we know how to place objects on the minimum and the maximum of the bounding box. How do we make an animation that goes from one to the other? Well, this is actually very simple with a map range node. And a map range node starts out as a float, and a float is just a single value with a decimal point. And floats in geometry nodes also are represented by one socket. So it's one socket and one value with a decimal point. But these are vectors, and vectors in geometry nodes are represented by one socket and 3 values, x, y, and z. So we need to change this to vector, and now we have one socket and 3 values with the x, y, z and all of these. And it's represented by the color purple. So if we bring the minimum to the 2 min here and the maximum to the 2 maximum here, what we're going to do is we're going to say from 0 to 1, we want it to go from minimum to maximum. In other words, when we adjust our slider, we want the 0 value of the slider to be the minimum value of the bounding box. And we want the 1 value of the slider to represent the maximum value of the bounding box. So that's why it's called a map range node, because we're mapping 0 to the minimum and 1 to the maximum. Okay, so what we need to do is plug this into the translation, the result, this vector here. And to demonstrate this, we don't want to move these values because we're mapping from 0 to 1. So we need this information in there. But what we can do is pull out this vector and let go and add in a vector here just to demonstrate this. And we are only concerned with the x value here. So if you remember, 0 on the x value is the minimum. But if I click and drag and I start dragging up, you can see that once I hit 1, it's now at the maximum value. And I'm going past 1, you can see nothing happens because we have this clamp here. If I uncheck clamp, it's going to go past the maximum bounding box there. So same thing here. If I go to the negatives, it goes past the minimum. So I'm going to keep clamp checked for now, and we're going to delete this vector because we want to plug this into our combine XYZ, because if you remember from last time, this X value is going into our empty move, which is this input here. So let's plug that in here. And now we have our empty move, sliding it from the minimum to the maximum of the bounding box. And you can see even if I go past, it stops at those minimum max values. And we can even make this even easier if I go to 0. If I hover over here, press N to bring up the properties and select empty move, we can adjust the minimum and maximum default values. So default is 0, that's fine. And then I'm just going to type 0 and then 1 for the minimum and maximum. And that's for our slider. So now if I drag my slider, if my mouse keeps going, it will only stop at 1 and 0. It won't go past those. So that's easier to visualize since we have this clamped anyway. Okay, well, how does this help us at all? Well, it's because anything we put here now is awesome. Now 1 is still at the end of the string, no matter how long it is. And 0 is at the beginning, no matter how long it is. Which means that if I come here and I put a keyframe on 20 at 0, and then I go to 40, and then add a keyframe at 1, these are the only 2 keyframes I need to add. And if I press play, you can see it goes from 0 to 1, always, no matter how long or short the bounding box is, or the string. Hi. My name is Justin. Obviously, though, we can't see the text here, so we need to change that. And that's pretty easy because we don't need to see the bounding box, so we can just Control and right-click to slice that. We just need that information for the movement of the empty. So we're just going to take from our realize instances the geometry, we're going to plug that into the join geometry, and now we can see that text just like that. So type in geo, and that's small. Then I can just add to it geometry nodes, and in real time, procedurally, it moves from the start to the finish. And this is exactly what we want. However, you notice that the gradient texture isn't moving along with our empty. So if you've been following with the past few videos and you are savvy with geometry nodes, you did notice probably that the empty in geometry nodes isn't driving the texture like the empty did in our regular 3D scene. So technically we don't even need an empty because we have these drivers. These sliders are drivers that affect the gradient texture directly. So I could completely delete all of this here. I'm just going to do it for demonstration's sake. So delete that there. You can see that this works still just fine. And the feathering and everything works just the same way. And then the movement also works with the driver setup that we have. Because what's happening is, let's see, undo that. In our geometry nodes, we have the input empty move here coming in and affecting the translation or the location of that empty, and at the same time it's also driving the position of the gradient texture, but it's doing it independently. And so even though the empty is moving from start to finish, something is happening with our gradient texture, but it's not going from start to finish along with this. And that's because this driver is now only going from 0 to 1, which is a small movement with our texture. And remember, that's because of this map range node from 0 to 1. But we want to actually get this texture to match the minimum and maximum values of the empty or of this bounding box, just the same way we did with the empty. Well, how would we do that? Well, the first thought you might have is to put in a map range node here. Let's go ahead and stop this. And if I do map range, change this to vector and plug it in here. Now we can map it from 0 to 1, but the problem is we need to grab these minimum and maximum values and plug them in here, which we can't directly do. Actually, it would need to go here anyway, in between here. And since these values are going to constantly be changing, depending on the text that we put here, we can't just type in something here. So let's get rid of this map range node. And we want to take the value, the result that is driving the empty from the start to the finish. We want to take the same result. I want to pull it over here to the group output node, just like this. And what that's done is created an output attribute here. So our vector here has created an output here, which we can give it a name of anything. So I'm going to say empty move. So you can put whatever you want in here. I'm just going to put that. And now over in our shader editor, we have something that we can add called an attribute. And I can type this in here or just hover my mouse over here, Control C to copy, and then Control V to paste that here. And now I can plug this into where the driver used to be. So just plug that one right back in. And now when we play, you can see the texture is now following the position of the empty. Of course, we have to mess with our gradient offset to get it to line up here. But now you can see that instead of having the direct driver that we did the copy as new driver and paste it here into this purple field. Instead of having that move it, essentially the attribute node from the output is acting as a driver itself. And the reason we need to do this is because there are no inputs that we can use for the maximum and minimum values. There's no sliders that we can copy as a driver because these are all based on node calculations. So we're using node calculations instead of a slider for the driver in the form of an attribute node. And this is super powerful. So now we have the same result, but just like with our empty, it now matches anything we put in here as the text. So become a member at blenderfrenzy.com. There we go. And now the empty and the gradient texture fit whatever length of text that we put in here, which is much, much better and much more procedural and leverages the power of geometry nodes so much better. We do have one more problem that we should probably fix though, and that is if we adjust the other sliders here, the gradient offset, which they're still being driven by these drivers here, which is fine. But let's bring this feather up here. Let's go to 9 and then shift and click and drag to have a little bit more accuracy. So we've got, let's say we want this amount of feather. Well, if we go to the beginning, you can see now our feather is coming in too early. Of course, I could just move my gradient offset so that you don't see any of the feather there, which is fine. But now at the end, we still have some of the text showing, and that's not what we want. So we need a way to have some sort of offset to where we can move the empty past this. Now, if you remember from earlier, we had this clamp, so if I uncheck that, we can move this past it. If we also change, we have to change the settings here. So let's do -10 and 10. So now we can move it past this -10 and +10 past whatever the starting and the end point is. So that's a way we could do it, but this still isn't all that procedural because then we'd still have to change and replace the keyframes if we wanted to change it. So I'd have to come here, set a new keyframe, and same thing at the beginning. And then if we didn't like that, in order to adjust it, we'd have to manually replace those. And again, we're leveraging the power of the procedure or the procedural nodes here. So I'm going to create a couple more sliders that will adjust the offset from at the end and at the beginning, and we will use the minimum and the maximum values to do that. And that's going to be pretty easy. All we need to do is add in a vector math node, set to add for both of these, so Shift D to duplicate that, and plug these in to the minimum and the maximum right before a map range node. And let's clean this up a little bit here. So we want all of this to be in the gradient frame here. Not the bounding box, but we want these to be in here too. Okay, so we'll bring the combine XYZ over here because this is plugged into the map range. And then I want to duplicate these. Oops. Duplicate these, and we'll plug this one in here. Same thing, because we're only using the X, we don't want all three sliders, so we just want to combine XYZ, or in this case, since we're going backwards, we're separating that. So we're separating the X out, just like we did with this one, where we only have one input over here, one slider. Same thing, so I'm going to duplicate that for this one as well. So this one will be our maximum. We can put that down here, and then this will be our minimum. And I'm just going to duplicate the group input, because you can, and disconnect this here, just to make things a little bit more clean. So this goes into our empty move, and then we're going to create new ones. So this is our minimum, I believe, our minimum. Yeah. So the minimum is going to come in first, and if let's pull this over here, make more room. This is the new X one we created. I'm going to title this empty offset BEG for beginning, and then this will be the same thing, but empty offset end. And let's move them up here. So this one will take that and move that right under the empty, and this one will be right under the beginning. Perfect. So now when we slide these, if I go negative, it's going to go into the negative offset. I can also go into the positive offset, to change that a little bit. And then at the end, if I drag the end offset out, it's going to drag it out here just like that. And now I don't have to change any of the keyframes. And now the text, the full text, is fully shown, and then it disappears fully at the end. And this is completely procedural. Again, I can adjust this on the fly. If I bring these back down to 0, you can see what happens. So it's like, oh, actually, this is not good. So I actually don't even need to do anything for the beginning. Although, let's see what the position of our empty is here. Let's see. Okay, so this isn't really lined up with the empty. So let's do the gradient offset to line this up a little bit more with that empty, which means at the beginning, we need to bring this out, this offset a little bit to match that. Okay, that's good. And then at the end, of course, we need to match this so we don't see the text anymore. There we go. Awesome. Okay, and then again, this is going to be geo. This is going to work with any length of text we put in here. Geo nodes. Just like that. And that is good. Don't forget to save your work. All right, and now we need to bring in our text, our orange text, and that is super easy because it's going to be using the same information. So let's just pull this out here a little bit. And all we have to do is right before the realize instances, we will do a join geometry. So plug that in here, and then we can join the orange text with the blue text. And when we press play, GeoNodes is awesome. Now, I don't know why. Oh, because I still have awesome in here. So let's plug this back into our string orange. There we go, because there's nothing in here that you can see. So we can say is totally rad. There we go. And the reason the orange text works right away is because in our texture with the gradient, this is the same node group. So if we tab out of this node group, this transparency node group that we created the first time is the same exact thing. It's an instance of the blue one. So these are the same node group. They're not separate, so changing one of them will change the other one as well. The only difference is the transparent shader goes into the bottom of the orange, and the orange goes into the top, and it's just flipped with the blue, which is why it's having the opposite effect. So as the blue fades out, the orange fades in. But it's using the same information with just those switched. It's using the same information with the geometry nodes here that we've set up, and it can be used with the same sliders. And this is the power of the procedural geometry nodes. So what can you do with this? Well, this is now your title animation template. So your title here and your subtitle here. There you go. So then you can sell this or have this as a download somewhere. And then all someone will have to do is download your template and plug in their own text here. And it will look exactly like this with their own text. So you've essentially created a template similar to what you would do in the Adobe Suite as like a MOGRT, motion graphics template. But now you have a Blender template. That is literally all they would have to do. They wouldn't have to mess with animation. They wouldn't have to mess with offsets or anything unless they wanted to.